Good morning, good afternoon, everyone, and welcome to a webinar hosted by the Cloud Standards Customer Council. We have just published version 2.0 of our paper, Interoperability and Portability for Cloud Computing, a Guide. So thanks for joining us today. Today, organizations are employing a wide range of cloud services and transitioning data and applications to cloud computing environments. Interoperability and portability are significant considerations, but there's some confusion and misunderstanding of what this entails. This guide from the CSCC aims to provide a clear definition of both concepts and discuss how they relate to the selection and provision of cloud services. ISO has recently published a standard for cloud interoperability and portability. That's ISO 19941. So this paper has been updated to reflect this new standard. My name is Tracy Berardi. I'm Program Manager of the Cloud Standards Customer Council and serving as our moderator today. And I'm joined by a few speakers who help to contribute to the paper. Mike Edwards, IBM Cloud Paths Evangelist and an active standards expert with ISO and the CSCC and other bodies. Carolyn Schock, Cloud and Cognitive Solutions Technical Leader at IBM, among some other excellent designations. And Mr. John Short, Technology Services Director and co-founder of Expert Thinking Consultancy in the UK. So a handful of CSCC members have contributed to this original document and its version updates. You'll find a list of the contributors. It's on page 3 of the paper. If you would like to download a copy of the full paper, we've included that in the Attachments tab on BrightTalk. There's also a PDF download of today's webinar presentation that you can access there. We'll be presenting for a good 40 or 45 minutes, so we'll have time for Q&A at the end of the presentation. So we encourage you to submit your questions throughout the webcast in the questions tab, and we'll do our best to address all of those towards the end. We're very happy to be here today. This paper is brought to you by the Cloud Standards Customer Council. We tap our large membership base in liaison organizations comprised of standards development bodies, open source project communities, and end user companies to publish vendor-neutral guides on important considerations for cloud computing adoption. So each deliverable that we publish contains extensive references to standards, best practices, and customer use cases. So on this slide, you can see a full list of the content coverage across 2017, and we're actively kicking off some new projects in 2018. Right now, we're updating our Migrating Apps to Public Cloud Services Roadmap for Success deliverable. We're targeting the end of February for that publication. And we'd like to publish a new cloud reference architecture for supporting AI, artificial intelligence. So stay tuned for some more great papers. And if you'd like to get involved by joining a working group or by simply becoming a member to receive email alerts and event invitations, just visit our website at cloud-council.org. It's a free membership, and we'd love to have you. So to get us started, I'm going to go ahead and turn this over to Mike. Mr. Mike Edwards, it's over to you.
Thank you very much, Tracy. Okay, so we'll start with asking a question as to why we had a second version of the Cloud Computing Guide. And compared now with when we issued version 1, cloud computing undoubtedly is now very widely adopted. So we have to reflect that in our paper. We note that the huge variety of cloud services available now has led to a number of proprietary architectures and proprietary technologies, and those definitely give issues for interoperability and portability. It's also now the case for many cloud service customers that they use multiple cloud services from different providers, and this increases the importance of interoperability and portability. It makes it front and center for many customers. In addition to those new challenges, we're also now have a new ISO standard that's been created and is published. This is the 19941 standard on cloud interoperability and portability, and it has some new thinking in it, which we didn't have in our original paper, the facet models, which we'll talk about later. And we've reflected that in version 2 of the paper we've got here. The whole risk of lock-in to individual vendors has become a bigger issue for customers, and so we've tried to reflect the ways in which customers should think about using cloud services to address that risk and reduce possibly its happening. There is also the whole question of the increased use of automation that we've had to reflect. Cloud computing has now very strongly become about automating all the processes that you might have that are involved with cloud computing, and we have to reflect that in terms of what is necessary for interoperability and portability. And last but not least, there are the arrival of new technologies, particularly containers and serverless programming, which changes the cloud computing landscape and again affects the whole question of interoperability and portability. So those are some of the reasons behind us needing the version 2 and some of the driving forces that have been involved in the changes that we've introduced in the new version of the paper. So let's move on to some basic definitions relating to interoperability and portability. Interoperability, we simply define as the ability for two or more systems or applications to exchange information and mutually use the exchange information. Straightforward as that. Effectively, this means public cloud services, private cloud services, and other customer systems that you may have, they must be able to use each other's APIs, the interface they present each other. And of course, the ideal is that you should be using standardized interfaces so that you as a customer can switch from one cloud service to another with as little impact to your systems as possible. Portability is divided into two separate areas. One is the portability of applications, called application portability, surprise, surprise, and then the question of the porting of data under the heading of data portability. So let's start with application portability. Here the whole question is the ability to migrate application from one cloud service to another cloud service, or between the cloud service customer systems and a cloud service. So both kinds of transition which might be involved. And the whole goal here is to require as few changes to the application code as possible, keeping it really simple. Data portability is the ability to easily transfer data from one cloud service to another cloud service, or between the cloud service customer system, where you may have your data today, and a cloud service. And this should be done in a commonly used electronic format. That makes it as straightforward to do as possible. And the APIs that the cloud service may have to retrieve or to import data are a very important aspect of this portability. And key elements of data portability are the syntax used for the data and the semantics, the meaning of the data, and we'll get into that more as we look at some of the scenarios. So those are basic definitions. Let's look at some of the challenges that are then involved in us doing interoperability and portability in these ways. So let's deal with interoperability first. One of the challenges for interoperability is there are usually multiple interfaces, multiple APIs across different dimensions. You may have an API for the specific functionality of a service, but that's completely different from the APIs you use to manage the service. So different interfaces to worry about, which may have different interoperability characteristics. Secondly, very common to find that interfaces are non-standardized. This is especially true for software as a service, but it is even true for other types of service. When looking at interoperability, I think it's generally agreed that infrastructure service, the basic compute, storage, networking services have probably the highest level of interoperability. Platform as a service is somewhat lower level because you're then worried about all the software stack that's being used to provide the PaaS and what interface that software stack has. And it may differ from one provider to the next. PaaS service has the lowest level of interoperability simply because this is just different applications, and applications you install and run on your PC, they do things in different ways even when they're generally trying to do the same stuff. And that's equally true for software as a service. The potential solutions here, well, we can use ESBs to help address things, to map between the different APIs, the ones the customer's using and the ones that the provider is providing. Or the alternative is to use some form of inter-cloud provider, a kind of broker, which does that mapping for you. Okay, moving from interoperability to portability. Again, different services offer different capabilities. For application portability, undoubtedly, infrastructure service offers the highest level of portability because basically it's your customer application that's getting migrated from one system to another. And in infrastructure service, it's a fairly low level interface machine, a virtual machine that's being provided. And so those tend to be fairly common. Platform as a service, because of the software stacks that are involved in platform as a service, may make application portability more challenging. Now, you often choose a particular PaaS because of the stack it supports. So that may not be so much of an issue, but even things like versions of particular software may be different between one provider and another, and that may cause you some challenges. For software as a service, it's data portability. Because you're not porting application with software service, you're moving from one application to a completely different application provided by a different provider. The big question is your data, when you move it from the one application to the other application, will it port? Do you have to modify it for it to be used? So, what potential solutions have we here? Well, in an infrastructure service, we have standard operating systems like Linux, standard image formats like OVF and Docker, which can help port your application over. The platform as a service, there are some various common open source platforms available, and those Cloud Foundry is an example where a number of different providers build out platforms as a service offerings using those open source platforms. And then last but not least, the common container technologies like Docker and Kubernetes do allow you to independently parse the application, and that can ease application portability. So those are some of the challenges you're going to face. Now I'd like to move on to some pretty pictures which help to illustrate the elements that are involved in portability and interoperability. This is a general picture of a customer, a cloud service customer, using a cloud service. So on the left-hand side, we have the customer systems. There may be applications in there, there may be data in there, and we divide the function that's going on the customer side to the user function with the actual use of the cloud space. We have the administration function where the use of the cloud service is being administered, and then there are business functions which deal with the business issues relating to cloud services, in particular invoicing, payments, or billing, all that kind of stuff, because you typically pay for cloud services. On the provider side, on the right, we have the cloud service. It provides a set of functional interfaces for the basic function it's offering, admin interfaces for doing the management and control of those services by the customer, and then business interfaces that deal with the business capabilities. Then within the services, we can essentially migrate our applications, so we can port our applications into those services that we're using. we can also port our data into the services again, and our customer data can live inside the cloud service. So those are the fundamental elements involved in portability and interoperability. So let's then take a look at how these elements play out for different kinds of service. For infrastructure service to start with, then the service itself is basically a little functional machine, place to store data, that kind of stuff. So in this case, we're particularly going to be concerned about application portability to know that the target environment that we've got is suited to the application we've got. And we've got to think about the application in terms of its artifacts and its dependencies. More about that later. In terms of the interfaces that we're using as a customer, then primarily it's going to be the admin interface that we're going to care about, because the user function is just basically, run this virtual machine, run this container. They're fairly simple, low-level functions, which are broadly similar between different IaaS-type services. But how the administration is done, how the business functions are handled, can be very different from one service to the next. Moving on from infrastructure, then we can also look at platform as a service. And here, in this case, the really big concern is that we're porting our application into an environment with a big software stack that we're going to depend on. And the big question is whether the environment for our application, when we port it, whether that environment is going to be suited to our application. And that extends to dependencies. If we need a database, we need to be sure that the database that the PaaS supplies, which is often the case, is the right version, has the right capabilities, does what our application needs. So in this case, we're emphasizing there on the right, around the application that's being ported, that whole environment needs to be examined in some detail. Then moving on from platform as a service to our final one of software as a service. Well, in this case, as I've said previously, we're not porting any application code. We're going to simply use application code in the cloud service. So there's no application portability involved here. The big question is going to be data portability. Does this new application that we're going to use handle our customer data in the form we have it now, or am I going to have to transform it in some way for it to be acceptable in the cloud service? So that's a whole big data portability question. Equally, all the interfaces that we're using, the user function, the admin function, and the business function, all of those could potentially differ from one cloud service to another, and therefore be an interoperability problem, which is much more significant for software as a service compared with the other forms of service. Okay, that's taken a sort of high-level look. Now I'd like to hand over to Carolyn to take a look in detail at the scenarios which form the core of our paper. Over to you, Carolyn.
Thank you very much, Mike. Yeah, and we cover in this paper 5 scenarios that are today just so common. You might have a customer who is switching between providers for their cloud service. So that could be anything from infrastructure to the platform to a software choice. You could have what is today extremely common, that you have a customer who is using cloud services from multiple providers and needs to provide integration between those. You have customer who are linking up one cloud service. Let's say they're using a set of data or some kind of processing function or data, storage from one cloud service, and connecting up to another cloud service, which might have, let's say, their preferred middleware, from that data store. Finally, you have the customers linking their in-house capabilities, so they have some on-premises applications or data with external cloud services. And then finally, when you migrate from one cloud service, an entire set of capabilities into another service provider. And when thinking thinking about all these scenarios, there's kind of to anchor yourself, consider always where the service responsibility lies. And Mike touched on some of that. If we're talking about infrastructure as a service, the customer, the service, is responsible for everything, the OS and up. They don't have the physical hardware, but they're handling everything in the stack above that. If it's platform as a service, then they're handling the application and the data. If it is the software as a service, the customer's responsibility in that case is typically their data and then how they connect securely to it, so more of a process issue. So here, we have the customer switching from their provider for a cloud service, and as we said, if this is the case where the customer is going from software as a service or the APIs and these user interfaces become a key concern. They're not always standard. There's still a lot of inconsistency between there. So how you connect, how you are moving data back and forth, how you're managing interoperability with, say, such things as your ADM is an issue. When we are looking at your infrastructure as a service and your platform as a service, the application portability becomes the biggest concern. And there are ways to deal with that. Of course, if you're an organization that has adopted open standards, you have not just adopted open standards, but you have a good program to assure that these are followed consistently for packaging and things, you can move things back and forth. If you're looking at platform as a service, again, open technologies, open APIs, an approach of management within your organization so that there is consistency will give you some assurance. If you are an organization that is really dependent on software as a service, you have handed off responsibility for all the middleware and the infrastructure, then it is in your best interest to look for very well-defined APIs, ideally a standard, look for something that is consistent between your providers, consistent protocols, and data formats. That becomes of the utmost importance. In scenario 2, where you're looking at the cloud services from multiple providers, you're interacting with 2 or more, some of the same considerations, in fact, all the same considerations of consistency apply, but then you also have to look at how you yourself are managing all of these systems. Do you have both a consistency in the admin, the management, and the business interfaces between them, which is unlikely, or are you going to have to come up with an interface, a service bus? Are you going to need to look for a way to aggregate your logs? Are you going to need to look for some provider of common or standard technologies to bridge some of these gaps? So there is more complexity when you add the different cloud services, and there is the need both to look for the standards and then come up with a way to manage the information, the data that's being produced. On the third scenario, where you have one cloud service and you're connecting it to another, this interoperability and security become the main considerations. And the concerns continue that you have the well-defined and consumable APIs, and you might be looking in this case at using another cloud service as an adaptive layer to simplify some of that management. Excuse me, I need to put on mute for a second. Thank you. So yes, the considerations continue here, and as I had perhaps not mentioned earlier, your data portability concerns continue, making sure that you have a manageable syntax, and the greater issue in scenario 1 and going forward is whether, of course, the extent and the semantics of your data are more or less the same. If they are not, then you're going to have much more complex issues in navigating those differences. And platform as a service, that becomes the most complex case for data because, of course, you might have syntax sensitivity and generalized formats to navigate. So moving forward to 4, this, I think, is the most frequently adopted scenario in the past couple of years where your customer is linking their in-house capabilities with a cloud service. Obviously, this comes into play where there are applications that did not have a cloud ready interface. In certain businesses, insurance comes to mind where you might have very old COBOL programs. And so you need to come up with a way to surface content or wrap functionality so it can be consumed on the internet. And the cloud services provide that. Now, obviously, you will need to have a very well-defined API for that on-prem data. The organization that is approaching their applications from a service-oriented architecture perspective, regardless of whether they have an actual ESB or some kind of technology, but if they are thinking conceptually about their data and their systems in that way, that is a great help. There is, of course, the need to how do you manage your in-house admin functionality and your cloud admin functionality. You'll have new security requirements. You'll have new data concerns as well. Where are those cloud services? Do you have data residency concerns that you need to work on? And there will very likely be new business interfaces that will have to be defined by your cloud provider. The other concern that is not specifically called out is if you are connecting your in-house applications to a cloud service, possibly because you're looking to create some kind of customer-focused application or use that takes advantage of the elasticity of cloud services, you will need to make sure that whatever is on-prem and feeding that system will be able to keep up as well. So that is another concern. And finally, there is this 5th scenario where the customer capabilities are migrated entirely into the cloud services. And in this case, if we're dealing with software as a service, there can be you have to look at the compatibility of data type. There could be API differences that you need to focus on, and that will have to be bridged. For the infrastructure and the platform of the service, you need to look at how easy or hard it's going to be to migrate your app to the cloud. Obviously, if you are an organization that has fixed on a particular standard, or you've adopted containerization in your environment, you might have a simpler time than an organization that has more monolithic apps. But those are the considerations to look at. You will, of course, have those new security requirements, and that could be anything from how your data is stored at rest and through transactions, as to setting up new rules for API integration. Do you have open APIs, and on and on. So it becomes more complex. And then finally, as it has been for the other scenarios, you have these compatibility of your admin and your business interfaces. Can they be integrated? Are you going to have more than one way of looking at it? Cloud management platforms really have grown in both interest and in quality and availability, directly in response to the complexity of multiple cloud services and integrating and managing on-prem and off. So those are areas to keep very much in mind, and keep very much in order for how you will both proceed with the migration and how you will sustain and manage those changes going forward. And at this point, I'd like to turn things over to John Short for a summation.
Thank you very much indeed, Carolyn. To recap then, our recommendations regarding portability and interoperability are as follows. For interoperability, ensure that your on-premises applications are leveraging service-oriented architecture design principles, that they can utilize and expose APIs to enable interoperability with remote cloud services. You may want to consider virtualizing applications and considering the dependencies or the opportunities to use containers, which are becoming more widely supported. The use of an enterprise service bus is strongly recommended to perform interface protocol and data transformations. This supports and addresses differences between on-premise applications and cloud services, as well as differences between cloud services from different providers. Within security, there are a number of challenges that you need to consider, but the opportunities to leverage the support of third-party identity and access management functionality to help authenticate and authorize access to cloud services, and that can be run either by the customer or equivalent capability provided by the cloud service provider, are both legitimate approaches to take. In addition, if cloud services need, from a security perspective, access to on-premises APIs or data, you can address the security issues by enabling access to the capabilities from the cloud environment, for example, by putting in place a suitable API management capability. And then finally, within that, when using multiple cloud service providers, ensure that security technologies you're using are supported by all of the cloud service providers, so that you get strong interoperability between them all. Within the interoperability recommendations, we would also state that we would encourage and request that the cloud service providers support key open technologies. So this is open standards, or indeed open source software as well, and in particular to focus on the admin and the business interfaces. And in doing so, that will make it easier for you as a customer to support multiple providers and make it easier to switch from one provider to the next as well. A couple of other points in and around interoperability. So look for whether the in-house systems are available to deal with the business aspects of using cloud services. Is something that both Carolyn and Mike touched on earlier on as well. And make sure that you don't end up with a situation where you have a technical solution that is good, but the impact in terms of business and cost is considerable. So you need to think about that. And as part of this, also make sure that the cloud service provider interfaces for admin and business are appropriate, are capable, and extensive, and that they can be used directly or integrated within your new or in-house systems. From a portability perspective, for IaaS, as it says here, we've got portability for IaaS, PaaS, and SaaS. For IaaS, infrastructure as a service solutions, ensure that the cloud service providers accept or use widely accepted standards for packaging, so formats such as OVF or Docker, and that the interfaces and the APIs are also open and standard. For PaaS cloud services, think about and consider the application environment and how open that is. From a migration perspective, you'll be migrating web services, database services, various other supporting ecosystem services as well, and make sure that they are either supported by the cloud service provider or it's compatible with your on-premises application environment as well, depending on the nature and the architecture of the solution. And from a portability perspective, ensure that the application environment is based on open technologies to increase the number of viable alternative cloud providers. For software as a service, SaaS services, consider and ensure that you use interfaces, APIs, and protocols and data formats that are well defined for those cloud services. And in terms of things like APIs, always insist whenever possible that they are standard and open, and the protocols and data formats you're using are equally portable as well. You need to, as part of all of that, the SaaS services, particularly the more complex ones that may have been considered as part of scenarios 3, 4, and 5, that you have good compatibility between the on-premises applications and cloud services, the cloud SaaS services as well, and make sure that there's compatibility across the different cloud service providers if you're running or planning to run a multi-cloud environment. And the final point, just sort of stepping back to interoperability for a moment, is the use of an intermediary, as in an inter-cloud provider, or the use of cloud management platforms as well, can significantly reduce the overhead in terms of integration, interoperability, and portability. And on that last piece about cloud management platforms, there is, in fact, a practical guide from the CSCC on that particular subject. Just moving forward then to standards. Not surprisingly, would strongly recommend the use of and challenging cloud service providers whenever possible around their use of open technologies and relevant standards, be they formal standards or more ad hoc but well-used standards that might be used, for example, within open source projects. We definitely consider the use of those, particularly when you're looking at more complex models of cloud, will significantly improve portability and interoperability and will reduce ongoing overheads and costs. In terms of the analysis we've done as part of this document, we found that in terms of cloud interoperability and portability, the level of standards within the infrastructure space is strong, but we're now beginning to see the standards around platform accelerating as well. So that suggests a maturing environment and a maturing market as well. I touched on briefly open source. There are a number of projects that have a very positive impact in terms of interoperability and portability. For example, within the IaaS space, you can look at things like OpenStack. And within the PaaS space, you can look at things like Cloud Foundry, Heroku, OpenShift, and also the Open Containers Initiative as well. And then finally, I'd draw your attention to the IEEE and NIST, who are working on a new standard, which is P2302 for cloud interoperability and federation. Those are the main points, I think, from a standards perspective. So perhaps Tracy or Carolyn, I can pass it back to you.
Yeah, back to me. Thanks, John. This is Tracy. That's a great summary. And thank you, Carolyn. And thank you, folks, for hanging on the line. That we had some audio issues with Mike in the beginning. He had to pop off, but thank you for hanging in there. And hopefully it wasn't too bad on your end. But just as a reminder as well, in the attachments tab, you can take a copy of today's presentation, as well as access the full paper. A recording is captured of this broadcast after we're done. So if you want to take a second pass at the intro, those resources are available. So now's a great time. If you have some questions, you can enter them for Q&A. And I'd like to remind you on the line, we have some links here if you're interested in getting involved with the CSCC. When you join, we'll subscribe you to our mailing list and keep you posted as new papers and webinars are available. And by joining one of our various working groups, you can contribute to these papers in a writing or reviewing capacity. We appreciate all the expertise we can get. We have quite a thriving community these days. And on this next slide, I've gone ahead and pulled out some other resources related that might be of interest to you. All of these are up on our website, cloud-council.org. We have a resource hub. They're all publicly, openly available. So enjoy. So now let's shift gears. Oh, Carolyn, hi.
Hi, would you like me to get to the questions that are in the chat from the audience?
Yeah, that would be great. Thanks.
Okay, well, there's a question here where somebody is asking how to know whether a cloud program contains a bug. Well, I'm not sure whether the person asking the question is referring to, let's say, software as a service where you've subscribed to use the application, or something that has been built and is being run on infrastructure as a service or platform as a service. But it pretty much comes down to, it doesn't matter if your software, your application is running within your own data center or in somebody else's, because obviously there still has to be some place where all that cloud stuff is. You need to have a test program. If you are writing your own software, you're going to have test procedures. You're going to have user acceptance testing, and that needs to be in place, and that would help you track. If you are subscribing to software and you're either using it as is or you're making modifications, you will typically, if you're making, say, changes, you'll have some kind of user acceptance test. It won't be as stringent, it won't be as automated, but you'll still have it. And the provider, the service provider, should actually have a protocol and communicate that to customers about how to identify problems, both, after a version upgrade, for example, or at any time, so that they can be taken care of. So if something does not seem correct, then you have a way to report it. The other question that is in
sorry,
the
Caroline, can I just jump in there for a moment as well, because it's a slightly it's not answering the question about specifically around a bug being contained within a cloud application or a cloud program, but it does raise, as you were talking to, an interesting subject, which is testing, and that is that clearly there is a set of functional tests that may well go through some kind of integration or UAT model, but as part of migration to the cloud, things like performance and stability testing may also be something that that you'd want to consider, and that really starts at the point at which you're architecting your application, particularly if you're looking at the later scenarios where you may be passing services from on-premise to cloud provider and back again. So something I would definitely consider if I was migrating applications across in those scenarios is to think very, very carefully about non-functional testing and make sure that you don't introduce as part of the migration to the cloud issues around data integrity, issues around performance or stability, as well as clearly, the ability when you're porting, if you're changing code, to introduce bugs along the way.
Oh, absolutely. That is spot on. And I would go so far to say as to each piece of tooling that you add into your overall cloud, environment, whether it's integration between applications, the migration tools themselves, and your management tools. If there is data transfer involved, you're going to want to test it out. You're going to want to test out access. So, John, that is just spot on and extremely necessary.
Carolyn, it's Tracy. If I may, a sister program managed by the Object Management Group, or OMG, is the Consortium for IT Software Quality, or CSCC, that develops automated quality measures that become OMG standards. They're standards for looking at security, reliability, performance, efficiency of code. So as that comes up, I think it's an interesting topic, and that group, CISQ, is looking at these things in the discussion of cloud readiness. So that might be a good resource as well.
That would be, and it's always good to look at what's happening, because what I find is that organizations are eager to move ahead with new technologies, and they don't always have in mind new ways to measure these changes, and they're not sure about how to adopt policies and programs. So what you described, Tracy, would be a great way to jumpstart that and to operationalize what needs to happen. Spot on. And the other question that's in the chat here is, somebody's asking, how does a user even know what cloud software was involved in his job? And I'm assuming that that's an end user somebody's speaking of, not necessarily a system administrator or an application administrator, but an end user. And I guess the best thing to say is that if everything is working for that application, it's absolutely correct that the end user shouldn't know all of the pieces that are happening in the background. However, what's going to be important is not that the end user knows what software is there, but the way that the overall application, overall system is designed is that there is a way for somebody, that there are error messages happening, that there are, whatever pop-ups to let an end user know that something has been completed, and that the way the application is designed at the back end, somebody is capturing and looking at what is going on so that somebody is aware of where a breakage might occur and how something would be fixed. But if we're talking about a true end user, they wouldn't know, and they shouldn't necessarily have to or care. And John, you might have something to say about that as well, assuming we're talking an end user.
Yeah, absolutely, and I think you've hit the nail right on the head there, Carolyn. Right, which is that you're absolutely right. An end user shouldn't necessarily know the source of the application that they're using, in much the same way that today an end user doesn't have to worry about the particular location of a data center. If it's on premise, then you can think about cloud services in a similar way. So yes, I think from an end user point of view, that they shouldn't know. And likewise, as you migrate from one provider to another, again, likewise, if the migration is well handled, well managed, your end user, again, you would hope would not recognize that you've moved from one to another as well.
And I think I can address this last question that came in, having spoken with Mike towards the beginning of the webinar. The question is it possible to get a copy of ISO 19941? That's this brand new ISO standard for cloud interoperability and portability. And Mike had advised us, because Mike is on that team, that this specification will be freely available, but it might take a month or two for it to become available on the ISO website. So put that bug in your ear if you're looking for a copy of it. You give it a little time, but they are intending to make this available. And it looks like that's it for questions. Any other final comments, Carolyn, John? I want to thank everyone for tuning in today. Oh, sorry, John, were you going to say something?
No, I was actually going to say basically that. Thank you for everyone joining. And obviously, if there's any questions, then I'm sure they can reach out post this meeting as well.
Absolutely. Yep. So the best way to do that, if you have any follow-on questions, send them to me. My email is tracy@omg.org. Very easy. TRACIE@omg.org. We'd be happy to get back to you. So thank you so much for joining us today. Thank you, John. Thank you, Carolyn. Thank you, Mike, who may be listening from afar. Have a great rest of the day, and we'll see you at a future CSCC webinar. Thanks.
Thank you, everybody.
Thank you very much.